So first we're going to look at directions inside of crystals. And so these conventions are used across all material systems and all crystal systems as well. So this is very useful across all of material science. And so for a specific direction inside of a crystal, we use square brackets. And so these square brackets tell us, all right, we're going to go in this one particular direction, and that particular direction is basically defined by where we choose to place the origin. So I'm going to start off here by placing the origin in the bottom right. And so this is going to be my x direction, my y, and the z going up here. And so let's first start off with an example of the 1, 0, 0 direction. So I'm going to go one full stop in the x direction, and so I can just draw that vector here. So this is the 1, 0, 0 direction. Let's do another example of the 0, 1, 0 direction. So I'm going to go one full stop in the y direction. Here we go. So 0, 1, 0, no problem. Now, the cool thing about, I guess it's cool because I'm a nerd, but the cool thing about these directions is that they just act as normal vectors, so you can add them together. And we'll use this property of directions and vectors to help us understand more complicated directions. So if we add these two together, we just get 1, 1, 0. And then you can just, use the in to tail approach to add the vectors together so that you can find this final direction here, which is going to be our 1, 1, 0 direction. All right, no problem there. So now, in general, if we want to talk about a kind of class of directions, we use what's called the family of directions. So these are denoted by angle brackets here. And as an example, the family of directions of 1, 0, 0. First of all, think about how many directions there are here. So I'm gonna, just take a moment here in a second to pause the video and think about how many unique directions are in the 1, 0, 0 family. So pause it for 30 seconds, work through it, and then come back. All right, so hopefully you were able to figure out the 6 directions. So they are 1, 0, 0, 0, 1, 0, 0, 0, 1. And also, there's the negative versions of these. So -1, 0, 0, 0, -1, 0, 0, 0, -1. Now, note that we don't put the minus in front of the number. This is kind of convention in crystallography and material science. Also, sometimes people will say instead of -1, and you'll hear me say this too, sometimes you'll hear people say bar 1, and that bar just represents the bar on top of the 1. So I always say bar 1, meaning it's like -1. Other people say 1 bar to mean -1. I think that's kind of confusing, but at least for this class, -1 is bar 1 and vice versa. All right, so these are the 6 different directions that are in the 1, 0, 0 family. Now, again, this is really only specific for cubic materials. You can't necessarily, just go through and find all the different directions just by permutating where 1 is at and then permutating where the -1 is at, because crystal symmetry denotes what family of directions are symmetrically equivalent. So now let's kind of try to use what we've learned so far to draw a slightly more complicated direction. And so that direction will be -1, 1, 2. So we're going to try to draw that one. So for this example, I'm going to place the origin here. And that's going to be my x direction, y direction, and z direction. Now, you can choose to place the origin anywhere you like, but the one caveat to this is that you really need to make sure to follow the right-hand rules. If you don't do that, then your answers are not going to be correct. So what do I mean by that? If you stick your index middle and thumb out, your index finger goes along X, your Y goes along your middle finger, and your Z goes along your thumb. So the right-hand rule, obviously. So for this direction, so I want you to try to draw this. So again, I'm going to pause for 30 seconds. I want you to try to figure this out on your own, and then we'll go from there. All right, so to draw this, so the first step, kind of gave you the first hint in the slide. So you want to scale the indices so that the largest index is not larger than 1. All right, sorry about that. We got a technical problem, so I had to restart here. So we're going to take the minus 112. We're going to divide it by 2 so that we can scale down the Z index to 1. And so our new direction, which is still parallel, but the length is different, is going to be minus 1/2, 1/2, 1. And so what we can do is break this down into 3 different directions. We can use the additive property that I showed a little bit ago. And so this is going to be just minus 1/2, 0, 0, plus 0, 0, 1/2, 0, plus 0, 0, 1. And so we're just going to add all those up together, and then that will give us the final vector. So in the first case, we're going to go to minus 1/2, so we're just going to come down here. And in the second case, we're going to go over in the y direction by 1/2 over to here. So that's the positive y direction. And then to finish it up, we're going to go 0, 0, 1. So we're going to go straight up to the middle of the top. And that's going to be our final vector here. So I'm going to make this red. So we're going to go from the origin and up here. And so this is going to be our minus 1, 1, 2 direction. All right, no problem for directions.